Hello everyone, welcome to my talk, C, no Eval, Runtime Dynamic Code Execution in Objective-C. My name is Zhou Zhi, and I work for Ant Security Lightyear Labs. I am also a CTF player of Blue Lotus and T-Deliverers. This is today's agenda. In Real World CTF 2019, we designed this challenge Dezhou Instruments. It was about iOS app exploitation. I will do a short introduction for NSExpression and how can we abuse it to run dynamic code and solve the challenge. Finally, we will discuss the impact on real-life attacks. So, let's start from this challenge. It was inspired by Untitled OOO grant of DEF CON 27 finals, which was powered by the only iOS virtualization platform. But I wanted something more hardcore, like running on a real device, and more fancy bug, more than just Stack Overflows, and even working on the latest 812 hardware. So let's try harder. Instead of replication or virtualization, this time we will have a challenge on a real iPhone XR running iOS 12.4.1, which was the latest iOS at that moment. Here are some comments from Twitter users. I think they're just trying to get their participants to find new jailbreaks so they can sell them to Apple. That must be an expensive challenge. So is this real? Seriously, this is a real physical iPhone running a custom app. The app looks like this. It is a calculator. It's written in Swift with all the symbols in the binary. The input vector is the URL scheme. All you gotta do is to use some native code execution to read the flag and send it back. The core logic of this app is quite simple. It takes the user input from URL scheme and creates an NSExpression, then print the result. It seems totally reasonable, because there are like 10,000 of posts saying how to use an NSExpression to build a calculator. Can anything go wrong with it? Let's take a crash course. Before we introduce an NSExpression, let's take a look at this NSPredicate class. It's a definition of logical conditions used to constrain a search, either for a fetch or for in-memory filtering. Here is an example for in-memory array filtering. This string, name equals Apple, finds all the elements that has a name property equals to a given keyword. It will be translated to two parts, the left expression and the right expression. Each part is an instance of an NSExpression or its subclasses. Here are some examples for the predicate syntax taken from the official documentation. Looks like we can do plenty of things with this language, such as comparisons, lookups, logical operations, etc. This domain-specific language acts like a lambda expression. Talking about lambda expression, there is another first-class citizen in Objective-C named block. You can easily tell the difference is that NSPredicate is based on a format string, while blocks are compiled to machine code. In NSPredicate, there are comparison, compound, aggregation, string and number literals, and identifiers to look up values from the parameter. It evaluates directly on abstract syntax tree instead of some kind of bytecode or even machine code. So, an NSPredicate consists of at least two NSExpressions. Now here comes the NSExpression. It can be an operand of an NSPredicate, but also it can be used independently. The syntax are exactly the same. It's like a language within a language. For example, we can do mathematical calculation with these two lines of code. If you take the format string to build an NSExpression instance, then we use the expression value with object context method to actually execute it. This expression is going to be translated to this abstract syntax tree representation. We can see that some of the operators are translated to function invocations, they are performed on this NSPredicate utilities class. For example, subtract operator are becoming this method from subtract, and the arguments are the subnodes of other function expressions. This expression equals the following Objective-C code. By reverse engineering this private class, NSPredicate utilities from the foundation framework, we can find all the implementations of the supported operator and functions in an NSExpression. By extending this class, we can even let the NSExpression to use more functions. Now, it's time to be Eval. Let's meet the Eval in Objective-C runtime. Eval is a function typically seen in script interpreters. It takes the code as the parameter and executes it dynamically. It's considered Eval because it has worse performance because it compiles the code on the fly. It's a possible vector for code injection attacks, so it often leads to security concern. And it's harder to debug the code with Eval because the code stack and the context may be incomplete. But Eval is for the interpreters. Objective-C is a compiled language. How come? But it seems like we have something very close to Eval. It's time to do almost arbitrary code execution. This is a documented feature. Function expressions. It was introduced by OS X 10.4. An NSExpression is not just something for elementary mathematics. These function expressions are able to perform arbitrary selector with arguments. For example, this line of code performs the selector last pass component on an NSString instance, and we can get the result. What's more, if the literals are not enough and the selector are not enough to call arbitrary Objective-C method, here is a cast function that allows getting arbitrary class by the name. We are able to allocate and initialize any known objects, which means almost execute everything in this way. For example, we can cast this NSURL to get an XURL class, and then allocate and initialize it. Sometimes we need primitive values in Objective-C methods, but strings and numbers in NSExpression are translated to Objective-C classes. If we need a primitive value, we can also use this function to perform some certain selector to get the integer or the pointer to a string. At this point, we are able to call plenty of Objective-C methods with an NSExpression. This is very close to the selector-oriented programming technique used by Project Zero in their iMessaging exploit. As you can see, this approach is available on PAC. But an NSExpression syntax is quite hard to write, so I use this function, this Python utility, to convert Objective-C messages to an NSExpression syntax. To sum up, an NSExpression or an NSPredicate are very powerful. They are not just for mathematics. They are powerful enough for native code execution, while it doesn't touch code pages at all. So the signature doesn't stop this attack. But the limitation is so obvious. We can only use one expression at a time, one-liner only. There is no control flow, only compound Boolean expression, and local variables are only supported when the evaluation context is an inexmutable dictionary, which means we cannot call methods on the same object twice. But it's still enough for plenty of things. Due to a mistake that I made, this challenge binary was not actually compiled to ARM64E. Though we did have an iPhone XR, return-oriented program is still working. All you need to do is to take over the program counter register. So, we can use this NS invocation invoke using INP to control PC register and start loop. Due to the limitation of NSExpression, we cannot just assign a newly created NS invocation or something like a local variable and call its different selectors multiple times. Here we use a gadget from NS invocation operation to initialize an NS invocation with a valid target in an one-liner expression. Then we get the invocation property to get this invocation class instance. And finally, we will pass the desired PC value to this invoke using INP method to take over this program. Now translate this series of code to an NSExpression. As you can see, we successfully take control the program address to point to 414141. We can also defeat address randomization and even pack by using the following functions, which simply cause dealsing. Now it's time to solve the challenge. We actually gave a backdoor in the program in case you didn't find the cast operator in Foundation Framework. Now we can use few steps to read the flag and send it back. First, we need to get the path to this flag file. Then we use an NSData and initialize it with the contents of file and encode it to base 64 encoding. It's very convenient to make an HTTP request in Objective-C runtime. We just use this NS URL and call data with contents of URL from NSData, and we can, by fetching the content to NSData, we actually send a GET request to the remote server, which will bring the string content of the flag. Now, convert it to an NSExpression syntax. It looks like this. Finally, since we are taking input from URL scheme, we have to encode it to a URL. Here are some mistakes that I made in this challenge. Due to the limitation of the LLDB debug server, the flag checker, which was running on an iPhone XR, isn't actually using URL scheme, but arguments instead. So it had a bug that I didn't notice, that URL scheme didn't work at all, leaving some confusion for the participants. Though we were running on an 812 device, the victim app wasn't actually compiled with pointer authentication code. But as for today, store apps are still not getting PAC protection. Now it's time for some real-life attacks. First, it could be abused by malwares. Because with this technique, we can bypass App Store review to run arbitrary code. Compared to the previous approach, like JavaScript core and some binding, NSExpression and NSPredicate are much harder to spot because there are no dealsing or NS class from string. They just look like legal code. This is possible for the Eval apps that described in Unix 2013, because we can run arbitrary code in this way without being observed. And it's a possible code injection vector. Remember our previous talk on turning SQLite injection to native code execution? The talk many birds one stone, exploiting a single SQLite vulnerability across multiple software. An NSExpression injection kind of look like this. The format string is expected is supposed to be a query string, but actually it has the ability to execute arbitrary native code. With all these functions found in this family, if we can fully control the format string, we can turn this injection to native code execution. But if we can only control the parameter binding, for example, argument array or arguments parameter, they are still safe to use. One more thing is that when we can fully control the format string, it is an old bug because it is a real format string after all. For example, if we feed this %p to an NSExpression, it will actually return the address of the first argument which points to this NSExpression instance. So the classical format string attacks are available in this function, and the compiler doesn't warn us about it. For the code injection vector, if we can fully control this format string, we can just put some function expression inside it and call any code we like. But the second line of code, which the input is in the argument array, it's still safe to use, just like parameter binding in SQL. So here's today's talk. If you want to go deeper on this topic, you can check out those references telling you more about NSExpression and NSPredicate. Also, here are some write-ups from those teams that successfully solved this challenge. The approach they use may be a bit different, but they are all expected. And finally, here's the source code of this challenge if you want to check it. Now, thanks for listening to my talk.